right, hello my mathematicians. Today we are doing Unit 1, Lesson 3, making scaled copies. And our learning goal is let's draw some scaled copies. So we're going to start out with a little bit of a mental math exercise here where we're going to decide is it more or less. So if we're looking at the value of 25 times 8.5, is it going to be more than 205 or less than 205? Well, if we think of 8 times 25, like 8 times 25, that's going to be 200. And 0.5 times 25, so if we think of that as 50 cents times 25, that's going to give me $12.50. So if I add that to the 200, I know that it is going to be more than 205. So that's a way to think of it using mental math. For number 2, the value of 9.93 times 0.984, is it more than 10 or less than 10? Well, I would kind of look at this and say, okay, this is almost 10, and 10 times this would be 9.84, and I rounded up, so that means to me it's going to be less than 10. Another way to think of it is this is almost 1. So 1 times 9.93 is going to be less than 10. And since I rounded this up, it's going to be less than 10. All right, the value of 0.24 times 0.67 is more than 0.2 or less than 0.2. Well, 0.24 is a little bit less than 1/4 because 1/4 is 0.25. And if I round this up to 0.68, that makes it easy to take 1/4 of it, which would be 0.2. So I have rounded this up and rounded this up, so I'm going to say that it is less than 0.2. All right, so for today's interactive digital version, here is the website. You can also find it by clicking on the open up button on the home page. If you don't want to do it interactive, if you want to do it in paper and pencil or just do it on your iPad, that's fine. You can do that. So it says draw a scaled copy of either figure A or B using a scale factor of 3. All right, so I'm going to try A. Maybe you could try B when you do it. So I'm going to count this. This side is 2. This side is 3. This side is 3. And if I want a scale factor of 3, remember that means I'm going to multiply all sides by 3. Now, why didn't I measure this? Because it's on a diagonal and I'm not exactly sure how long it is. But if I draw this, it should be the same. So I'm going to draw my first line, 2 times 3, so I'm going to go 6. So 1, 2, 3, 4, 5, 6. So this side is 6. 3 times 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go 9 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'll take a straight edge and connect these two sides together. So this was 9 and this is 9, and that is my scale factor of 3. Okay? Now I could test the angles. Well, we know this is a right angle, this is a right angle, this is a right angle. I could take my tracing paper and see if this angle equals this angle. Remember yesterday we talked about the angles stay the same in scaled copies. All right, now it wants us to take either C or D and use a scale factor of 1/2. So I'm going to try C. So I'm going to count all these sides. 2, 3, 4. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, and that one will be okay. All right, so I'm going to start out with this side here. 1/2 times 2 is 1, So that line's going to be 1. 4 times 1/2 is going to be 2, so I'm going to come down 2. 3 times 1/2 is 1 1/2. So that's about right there. Then, whoops, I left out this one. This one's going up 2, so half of that is up 1. Half of that is half. Okay, half of 5 is 2 1/2, so 1 2 1/2. Half of 6 is 3. 1 2 3. Oh, look. That matched up with that. 1 2 3 4 5 6 7. 1 2 3 1/2. So 3.5, 3, 2.5, 0.5, and this one was 1.5. So I have created a scale copy that is using a scale factor of 1/2. So I hope you try maybe B and D and see how you do on that. All right, our next activity is which operation. So Diego and Jada want to scale this polygon so that the sides that correspond to 15 units right here in the original is 5 units in the scaled copy. So they want to make this 5 units. Okay, so let's look at their finished copies. Well, here's Diego's, and here is Jada's. So this side is 5. This side is 5. So what operation do you think Diego used to calculate the lengths for his drawing? So it looks like he got 2 here. So let's go over here and see what we got here. Oh, there's 12 here, and he only got 2. So what does it look like he did? Well, he got 5 here. Let's look at this one. Or let's look at this one. That one's even easier. He got 8. So does it look like he subtracted 10? Okay, so I think Diego subtracted 10 from each side. So what operation do you think Jada did? Well, she had the 15 and now she's at 5. This 12 went to 4. So how do I go from 12 to 4? I can subtract 8, but that's not what I did there. Oh, are they multiplying by 1/3 or dividing by 3? Which is the same thing. So multiplying by 1/3. Let's test it here with this 7. Whoops. So this side is 21. 21 times 1/3 is 7. Oh, so it looks like she multiplied by 1/3. Did each method produce a scaled copy of the polygon? Well, let's look at Diego's. Did it make even a copy of it? No, it doesn't even connect. Is Jada's a scaled copy? Yes. So multiplying by 1/3 gave us a scaled copy. Whereas subtracting 10 didn't even make a closed figure. It didn't even make the polygon. All right, so part 2. Andre wants to make a scaled copy of Jada's. So he wants to make a scaled copy of that one. So the side that corresponds to 4, right here, in Jada's polygon is 8 units in his scaled copy. Andre says, I wonder if I should add 4 units to the lengths of all the segments. What would you say in response to Andre? Well, let's go back and look at what we did here. Diego said, let's subtract 10. Did it work? No. Jada said, let's multiply it by 1/3. Did it work? Yes. Okay, so let's look at this. Whoops. Wrong page. Here we go. All right, so do you think if we add 4, is this going to work? If I add 4 here, that's going to give me 8, but if I add 4 here, that's going to give me 11. I add 4 here, that's going to give me 14. And I am betting that it is not going to end up being a closed, it won't end up looking like Jada's drawing. Because we have discovered that we don't add or subtract, we multiply the scale factor. All right, so now it says create a scaled copy that Andre wants. If you get stuck, consider using the edge of an index card. So I have a little index card here, or a piece of paper to measure. So we're taking this 4 side and we want to make it 8. Well, if I mark that there, that's my 4 side. I'm going to do 2 of those to make it 8. So I'm going to draw 1, 2. This is 8. Okay. Then I'm going to come over here and I'm going to mark this side. Now that's 7, and I knew I took 2 of those, so I'm going to take 2 of these, and I'm going to try to do my right angle. So I'm going to take 2 of these. Okay, so 2 of those would make 14. All right, let's try this one now. Let's put it over here. All right. There's my 5. I'm going to do 2 of these. 1. Whoops, you can't see what I'm doing. 2 of these. So that makes that 10. All right, then we got this long side right here. That long side. Let's measure that right here. So that goes to right here. So let's do 2 of these. Looks like I'm going to go up into my writing, but that's okay. Okay, so that side is 20. Then I want 2 of these. Oh, I hope I don't run out of room. Which measurement? Okay, this one right here. So I need 2 of these. Oh, looks like it's going to fit. Okay, and then this should line up with that, and it doesn't exactly, and that's probably because my angles are not exact. So we're just going to kind of... Okay, because I didn't use an angle to make sure I was making exactly right angles, it doesn't match up exactly. But it's pretty close, considering I'm not using, I didn't worry about the angles, and I'm just using a piece of paper to do it. Okay? All right, I hope yours came out a little bit better than mine. So then, are you ready for more? The side lengths of triangle B are all 5 more than the side lengths of triangle A. Can triangle B be a scaled copy of triangle A? Well, when we were talking about this, when he subtracted 10, it didn't work. When we added 4, it didn't work. We had to double it. We decided it had to be multiplied by the same thing, not added or subtracted. So, can this ever happen? What if it's an equilateral triangle? Will it work then? So, the side lengths of triangle B are all 5 more than the side lengths of triangle A. So, if triangle A is an equilateral triangle, didn't draw that very well, let's say that has lengths of 1, and I add 5 more to it, so that would be 6, 6, and 6. Are they going to be scaled copies of each other? Yes, they will. But what's the scale factor? The scale factor isn't 5, the scale factor is 6, because we multiplied this by 6 to get to here. Now it will change based off of what number you have here. But we can just add 5 to it and it would work. All right, so the summary, the big takeaway from this is creating a scaled copy involves multiplying the lengths in the original by the scale factor. So we would have done this in the warm-up for class today. So I hope that helps you, and you get to do the practice problems now. So let's hope we've grown our math brain a little bit, and I'll see you on Zoom.